my thoughts on what we're going to cover. So again, this isn't by slide. This is by going through code and walking through and asking questions. Is call filters, right? Reference counters on accounts, and palette instances. Are there any other topics that people can think of that at a high level that they may want to see today? Because it's nice to know it now, so maybe I can tie in multiple ideas together. But these are some things that I think people have asked about or heard about, and we didn't really cover, and I can best show you in the code kind of how it works at a high level. Yeah, sign extensions, I think Uncon will do something about it. Yeah, but if he does it, it depends on what he covers. If there's more you want to know, we can do that after lunch. Yeah. Any other, just any other buzzwords you heard about frame or palettes that you're like, oh, how does that work? Or what does it do? Yeah, please go ahead. It's okay. You can just scream it. It's fine. It's fine. Off-chain workers. Yeah. Let's do a brief look into off-chain workers as well. Okay. Great. So we're gonna be going over these topics. It will be very much Okay. Yeah. Please. One more. Yeah. Oracles. Yeah. Off-chain workers and oracles are related. So I'll show you an example inside of the substrate thing, which is an off-chain worker oracle example. There's actually one already there. It's not like production ready, but it's there because the idea. Okay. So again, this is definitely kind of again, I'll be walking through code, talking about ideas. This is very much open to questions, so please raise your hand if there's any, and hopefully you'll be able to walk away. What I really want to emphasize is, even you might see me live coding or answering questions. I don't know the answer to all this stuff, but what the most important thing you can learn from this academy and for your future in Polkadot is how to learn about stuff you don't know, right? So in walking through this stuff, I'll give you ideas of how, just navigating the code base can give you answers to questions. And I think that's really the key piece here, okay? Another thing you might know if you've been in the space long enough, that as soon as documentation is written, it's out of date. So it's one of those things too, where documentation can help you, can give you high-level ideas, but really the truth is in the code, okay? Any questions before we get started? Okay, great. So let's start with call filters. Let's talk about just the high-level idea here. So let me see if I can find it. I'm going to go into the runtime. I'm going to go into, runtime folder. So I'm going to go to a different repo. This is a cool arcade machine. Runtimes. Open Visual Studio Code. I should give this its own color. Okay, runtimes are ugly brown. I don't know. Okay, and then let's go to Kusama. Why not? Kusama is fun. We talk about Polkadot a lot, but Kusama is its crazy cousin, right? And somewhere here we should see filters. Instance filter? Yes, this is it. Proxy type filter. Here we go. So let's talk about a high level. High level is this. We know about creating extrinsic palettes. We know about call dispatch, right? Basically, a call comes in an enum, and we actually go and dispatch the logic and to actually call the function, right? Why not add a layer in between the dispatch logic where we can actually filter out calls or have logic around like access control for certain calls, right? So some ideas and places we've used call filters. When we first launched Polkadot, we had a call filter where every single call, except for the calls related for consensus and staking, were disabled. So when you first launched Polkadot, you couldn't transfer tokens, you couldn't vote in governance, you couldn't do pretty much anything, right? We wanted to make sure the network was stable and running for a couple of weeks, maybe a month or two, before we actually went and enabled balance transfers, enabled governance voting, enabled all the other features of Polkadot, right? And one of the ways we would do this was a call filter. Of course, all of these palettes existed already in Polkadot, but we had a call filter to disable it. More, if you create a proxy, we talked about the proxy palette earlier in the slides when we went over all the different palettes. The proxy palette allows you to give someone else control of your account. Maybe you don't want to give them full control, right? Maybe you just want to say, okay, well, I let Keon be my staking proxy. That he can't transfer tokens, he can't vote in governance, but he can help pick validators for me, right? Or a governance proxy, someone who can make decisions on behalf, right? Imagine that there's a company that you own, you have billions of tokens, and you want to ensure there's easy access to vote with those tokens, but not to transfer or move them, right? These are all great use cases. And exactly, if you understand this dispatch logic of that we have this call and it goes in, you can imagine very simply adding a filter layer that can control it. So let's look at how we've implemented that and how it exists today inside of Polkadot and Kusama. So if we look here inside of our runtime, remember, from another thing that you should realize is that something like a filter only makes sense in the runtime. Only the runtime has context of all the palettes that you have, right? Only the runtime knows all the calls there. So you're actually able to create specific filters at that level. If I was creating a filter in the governance palette, of course I can make filters for my calls, but I couldn't make general calls, right? I wouldn't know any of the calls outside of my runtime. So let's look at this here. There's this instance filter for the proxy type. So these are proxy filters. And we have a bunch of different proxy types, basically. Like when I create a proxy, what kind of proxy do I want to create? It can be an any proxy. And you see it just passes to true. Every single call will pass through this proxy. There's a non-transfer proxy. And here we match that if it's a call to any of these palettes, what happens? If it matches any of these palettes, it returns true. Yes, it returns true. So you'll notice these are basically all the palettes in our blockchain which aren't a transfer, which isn't the balances palette, right? So this is basically a proxy that can do everything except transfer tokens directly. Does that make sense what I just said here? Right? And one thing I want to mention here is that obviously this looks really intense. Why not just say not balances, right? Because it is better in general for a production runtime to explicitly allow something than to implicitly allow things. Does that make sense? If I have just not balances and I add new palettes and I forget about this filter, then I might unlock a feature I don't want. It's way better we launch an upgrade with a new palette and people are like, oh, I can't access this thing I expected, right? We can solve that with an upgrade. If someone accesses something that they're not supposed to access and mess up the state, that's really bad for us. So even though this looks kind of nasty, right? And it could have some mistakes, it's much better than the alternative. Of course, you can imagine writing tests, you can write other CI pipelines which can handle this, but the idea of why we have here explicitly enabling every palette except for balances here is for that reason that we do not want to accidentally F up and allow something that we're not supposed to allow. Can we get a mic over to here?
Just to clarify, non-transfers allows transfer to anything that returns true. Like true means yes transfer, not a no transfer.
Non-transfer allows a successful call to any of these palettes. So if I enable you to be my non-transfer proxy, you can call the treasury palette and open a proposal for me. You can call the fellowship collective and enroll me in the fellowship. You can call staking and stake my tokens. What you can't do is transfer the tokens to someone else using balances palette. Right? And by the way, there are options here. Look at this. Look at this. For recovery, we didn't just say you have the access to the whole recovery. There are some functions inside of the recovery palette which are similar to transfer that you could take advantage of to basically enable a transfer. So we basically whitelisted the specific calls in recovery that were okay, and there are some calls which are not in here which don't allow us to backdoor transfer. So if you create a palette which you can imagine like they call A, B, and then C, and they're basically transferring a token, right? You might want to enable those calls or disable those calls. Do you see what I'm saying? It's kind of on you as a runtime developer to make sure this makes sense. I guess vesting is the same, right? So vesting, we didn't just enable. So specifically omitting recovery, create recovery, and initiate recovery. We're omitting these two because in the logic of it, somehow it might be a way to transfer a token. Specifically omitting vesting, vested transfer, and forced vested transfer.
So in the ones that are omitted, you are allowed to make a transfer.
Yes, but we omit it, so with this proxy type, you can't do it. So in the vesting palette, there's a call vested transfer. And you could make a transfer, and you can add a 1-minute vesting period, right? That would basically be a regular transfer. So we do not allow you to call this function because the purpose of this proxy is not to allow transfers.
I think I'm just confused by the name called non-transfers, where putting something in does allow the transfer. That's all.
No, sorry. You're not every extrinsic is a transfer. There's a call that says vote. There's a call that says it. So transfer is balance transfer, right? So this thing is called non-transfer. You agree that this timestamp palette doesn't have any extrinsics, which will transfer my token. Okay, so then what's the confusion? I'm allowing you to call timestamp palette because nothing in it will allow me to transfer tokens. That when I enable you to be a non-transfer proxy, I want you to be able to do calls which don't transfer my tokens.
Okay, got it now. Thank you.
Okay. Okay. Obviously, there's a governance, and this is much smaller, right? So if I allow someone here, one of you, to be my governance proxy, I'm allowing you to vote on my behalf with my tokens, right? Vote. And in this context, very simple. You get access to, I guess, like bounties or conviction voting or referenda. These are the basic governance palettes. You also get access to utility so that you can batch calls for me, right? Now, again, at no point can you transfer tokens, but you can, or at no point can you, I guess, open a treasury proposal for me, but you can vote on things, right? So again, you can imagine, and these are just enums, right? So in the context of the runtime, you know every single palette and every single call you're including. It's explicit. It is known here at this compile time, right? So you can create whatever proxies you want with whatever calls you want or palettes you want at what level, and basically take advantage of the filter. So that's the first step. Now we're going to actually go look at the filter system, okay? Any questions about creating a proxy? Can we put the mic up? Yeah.
Like, where exactly does this fit in the macro sense of things? Like, between the runtime and
Yeah.
between the frame, the palette.
I think I think I understand your question. Basically, like maybe where in the frame stack does this plug in? I believe this plugs in the executive. So we're parsing transactions, and we're dispatching calls, and the dispatch logic inside of executive has logic to handle filters. But I think let's look at the code maybe, and we can actually find that.
Sure, okay.
I think that's better. That's a great question. But we'll follow that next. One thing else to notice here. Look at this function here. Is superset. Let's figure out what this is doing. X, Y, if X equals Y, it's true. Process any, true. That, any, false. So, okay, so this is basically trying to find supersets between different proxy types. So given two proxy types, this is the self. If the two proxies are the same, they are the superset of each other. They exactly are the same. If you have proxy type any, it is a superset of all other proxy types. If you have some other proxy type, it is absolutely not a superset of the any proxy type, because if it was the same, it would be here. So if it's anything else besides any, it will not match. If it's non-transfer, and at this point, if we got past any, if it's at that point non-transfer and anything else, it's true. So I'm not exactly sure off the top of my head where this is used, but this logic makes sense in general. Somehow is trying to analyze between two proxies. So it could be, I think, maybe in the proxy palette, I can give you non-transfer proxy, and then you create a proxy call using a lower level proxy, and as long as it's a superset, we allow you access. So that's the idea. I'm not sure exactly how it's used, but I remember that there's a way when you make a proxy call, you just specify what level of proxy you want. So if you have non-transfer and you want to use governance, that because non-transfer is a superset of governance, that this passes true. And otherwise, it's false. Okay? So just an idea. I mean, this logic makes sense. How it's used exactly? Meh. Okay. So somewhere inside of our runtime, this object must be configured, right? And who wants to guess which palette it goes into? Either system or proxy. That's my guess. One of the two, right? So let's figure it out. So I'm just going to take this object proxy type. It's a struct or an enum. And let's just figure out where it is. Blah, 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 blah. Okay. Proxy palette. It's right there. So there's some proxy type going into the proxy palette, which is taking this definition. So again, the proxy palette has some logic, which is generic. It doesn't know what exactly it's doing, but it has an API to tell me, given this proxy type and given this call, give me true or false. We have defined in our runtime exactly that logic. Given some proxy type, given some call, give me true or false. And then if we go inside of the runtime, inside of the palette, I mean, let's take a quick look. So we go to Polkadot SDK. We go into proxy palettes. And then if we go here, you can see here there's whenever you make a proxy call or you make a new proxy, you specify what type of proxy you want. So you can add a proxy delegate with a proxy type, right? And that's generic. That's controlled by you in the runtime, right? And I think somewhere you make the call proxy. Where's the FN proxy? Here, there is a function called proxy, I imagine. Add proxy here. So you can proxy, and I guess here this is where this that checking statement comes in, the superset statement. You can force a proxy type with here. So I guess let me think why would this be useful? I can think of one use case off the top of my head. Could be useful if, for example, we create a new proxy type, like proxy for NFTs, and we forget to add the calls to none transfer, right? So none transfer might be saying no to this call, but because none transfer is a superset of all other proxies except for any, you get access. Anyway, not a big deal. I'm not exactly sure the exact reasoning, but that's one idea. So we go into here, and let's see. So there's a proxy type, and then what we go in here at some point, let's see, let's go back to this thing. The function we implement here is filter, right? So somewhere in here, I should expect to see dot filter. Perfect. So here coming in to do proxy, you can imagine this is actually doing the proxy call. We're going to go in and check before the C is a call, right? The C is a call type. We're going to take the C call type, and then we're going to filter it through our proxies. Something like that, right? That's the general idea. Again, it's not rocket science on how this works. You can walk through the code. But the idea is then, once we've filtered out the calls, only after the filter passes do we actually do call dispatch. One more thing to note about these filters. There's this dot dispatch bypass filter. So this is being used, I can imagine the most obvious use of this is in pseudo. So remember, we talked about pseudo. Pseudo is basically taking a user, making them root, right? That in the context of root, you should have access to everything. There's no rules around that, right? So if you are a user with root access, we can call dispatch bypass filter on the call, and this will just bypass any filtering logic. Who knows how the runtime was configured? Who knows what was enabled or disabled? But we just bypass all filters and allow it to call. An example for when this was used was, again, I talked about the early days of Polkadot. We launched the token. We had a filter on all the calls by default that said don't call, that you cannot allowed to call any of them, except for a few. But we did have access to the pseudo palette, because there was pseudo in the early days of Polkadot. And we had bypass filter. So if we need to do a balance transfer, for whatever reason, something really important needs to happen, we could bypass our own filters through pseudo. And when you write your code, if you want similar logic, there is a dispatch call with bypass filter. Okay, let's bring a question in the back, please. Microphone? Thank you.
When we say call dispatch filter, dispatch without bypassing or normally, so that call is also being executed, but fee payments, and this is a bit off topic, but I came across that line when pay fees no at the end after dispatching the call.
So you want me to find pays fees no's?
No, just the previous.
Okay, so let's go back to pseudo.
Yes, pseudo.
So if we go to pseudo, yeah.
We were just seeing it. Yeah.
So this is the same thing I taught you with the free transaction palette, right? Okay.
Yeah. So call dot dispatch. This res. So that operation is done, and then it comes back for the fee payment and all, and then
So,
this.
I think I know your question. Your question. Call.dispatch does not take fees. There's no feed logic in dispatch. Dispatch is literally just calling a function inside of Rust. The fee system happens in executive, or before all this stuff, before the extrinsic even comes in. So the fee is all about here before you even come into here. But once you run this function, there's no fees. And by the way, if you run tests, there are no fees in there either. So I think there was a question in the live coding. I'll show you how to check fees in tests. But there is no fees from the dispatch.
Got it. Yeah, that was the question. Got it.
So there's no fee here, and this pays no has no effect on this. It's affecting this.
Yeah, makes sense.
There's
okay.
Dispatch, again, dispatch is not the pipeline of an extrinsic. It is not the pipeline of a transaction. Dispatch is literally dispatching a call to a Rust crate function.
Okay, makes sense. And weights are obviously included in that.
No, not by default. So look at this. If I want to make this call dispatch, this is not taking into account weights. Look up here. In my weight logic, my dispatch info, I'm getting the call and getting the info, and then I'm adding the weight of pseudo to the weight of the call.
Okay.
So I have to write code which is handling the weight ahead of time. So I know the call because it's coming in as a parameter. I'm able to very lightly, very cheaply, get what the weight is and add it to the additional weight of a pseudo where it's just pseudo, just this logic, right?
Got it.
And the sum of these two is the weight of the whole call.
Got it. Thanks. And another question: when the call is filtered out, and that filter returns, that's not here, but I'm just asking.
Okay, when the call is filtered,
Instance filter just filters it out and returns false.
it returns
then
true or false. Yeah.
Yeah. So what kind of error comes? I mean,
What kind of error?
yeah. So call not allowed or this account is not allowed
Yeah.
to
So
do
what
that,
happens? What happens when the? That's a good question. It's probably a dispatch error. My guess is this. Let me check. So let's go to enum dispatch error, and I bet you I would see here some kind of filter. Other module, consumer, no provider, arithmetic, transactional error. Maybe that one. Nope, that's the transactional layers. Enum. I don't know. Let me look closer. So I showed you right here. So I'll find the answer, but let me keep going and I'll touch it. But you're right. I don't know exactly now. Let's go back to the runtime. So I showed you one instance of a filter from the proxy type. I want to show you this exact same logic is used, but at the system level for a general filter. Okay. So inside of frame system. Inside of frame system config, there is this base call filter. This is exactly the same type as the proxy call filter. It's exactly the same structure, exactly the same trait, etc. But this one is a base filter for everything. So for the proxy type, when you have a proxy, we check that logic. When I mentioned to you with Polkadot, how we stopped everyone from doing transfer, we put a base filter with transfer equals false, right? And basically now, today, the base filter is we support everything. The base filter is all the calls are okay. There's no reason there's any call that we don't support. But you could create a base filter. No one can call this function, right? So it's exactly this, exactly the same structure. I could put in here, exactly the same structure, and it would match. So it's the exact same trait type. So actually, using this information, I'll go find the answer to your question. So let's go to frame system. Frame system. There's a base call filter, right? So basically it's a trait contains, and it contains a bunch of runtime calls. This basic call filter to use an origin. All origins are built with this filter as a base except root. This works as a filter for each incoming call. The call needs to pass this filter in order to dispatch. Otherwise, it will be rejected with call filtered. There's your error. This can be bypassed via dispatch bypass filter, which should only be accessible by root. This filter could be composed of subfilters by nesting them. For example, inside both, these except, everything but, etc. The default would be everything. So again, the goal of this is just to show you this, give you a big example. Now you have the tools. If you're building the multi-sig palette and you think of a cool way to use this or whatever other palette you want, It should be pretty easy to add, actually. It should be pretty easy to add this filter. And we can maybe just look a little bit more at how the code looks. So somewhere there's a base call filter. It must be somewhere else. It must be deeper in the code, right? So I think it's in, so base call filter. My guess is an executive. My guess is that this is an executive. Ooh, there's so much. Let's go : : Here. Scheduler, utility, referenda. Huh. None of these are exactly actually what I expected. Or maybe it's something else. Maybe it's let me just go into executive. Again, my gut is that that's the place where it makes the most sense. Substrate, frame, executive. Let's search in this folder. Base call filter. Okay. Filter. Really? Where else could the base call filter? No, but the thing is, utilities isn't always used. Maybe it's in frame support. So the next one would be even deeper in the code, would be frame support. Ooh, that's not what I want. Frame support, find in folder. Filter. Here we go. No, but these are. Oh, here we go. Unfiltered dispatch. So here, there's, in the dispatch, obviously, in the dispatch log. So inside of frame support, so here's the pathway. Construct, and by the way, if you want to know about the pathway for building dispatch logic, Rust state machine. We really build this for you, and you build a macro for it. This is end to end. Inside of construct runtime, we generate the code which dispatches all of the calls to the pallets, right? Only the runtime will know these are all the calls, this is the outer runtime, and here's the logic for this enum goes to this function call, right? That kind of makes sense. So construct runtime has this. And the construct runtime macros, when they generate this dispatch code, again, remember when we call .dispatch, you're actually calling this function. This is literally the function you're calling. Here's dispatch bypass filter. These are code being generated for you in construct runtime, right? And at this level, it is handling the filter. It gets the filtered call, it checks it, and stuff like that before it dispatches. So this is happening, this dispatch logic is happening for you inside of that. And again, I'm really gonna emphasize, I've heard, I don't know if you guys are lying to me because you want to make me feel good. I've heard good things about this tutorial I made. By the way, there's different links to it because the tutorial itself is open source, so anyone can go and make a UI for it. So this is another UI for it, .codeschool.com. Shout out to Batman. In the Rust macro, here, executing calls and executing blocks and dispatching calls. So there's a whole section teaching you how to do function dispatch. Create your block type. Let's see the thing here. We'll actually go and teach you how to dispatch calls. Right? All of this code to create FN dispatch, you can create yourself. So again, really cool tutorial, maybe after the academy. Okay. I think that's pretty much all I wanted to cover with the filters. Any other questions before we move on? Generally, we understood what's going on here, right? I think it's not too complicated, right? And really, again, it's already piped in, so you can just create your own filter, no problem, okay? All right, next, reference counters. This has been a problem that you've definitely ran into if you were using any of the asset stuff and trying to create tokens for users, right? Like it was not allowing you to create a token for a user until that user had some funds. Okay? We inside of Substrate have a reference counter system to check whether or not an account is allowed to hold data, right? The objective, what is the objective? Going back to the idea of existential deposit, the objective of our new system is to be able to clean up dust information. We know that over the length and lifetime of a blockchain, that data accumulates and accounts stale accounts and stale data sticks around on the blockchain. And we know because of the Merkle tree that stale data can actually have notable impacts to the performance of our blockchain, right? The more nodes in our Merkle tree, the larger our Merkle tree gets, the harder it is to access data, right? So we want in general to be able to clean up accounts that have a low balance, right? But what happens if I'm an account and I'm playing with all of your palettes, and I have data in all these different palettes, and I'm the only one who can clean up all this data, but then I delete my account by transferring my whole balance. Then I leave all of these palettes in a state which is unfixable, kind of, right? The solution to this is that we have on the account itself reference counters, different kinds, and we'll walk over them briefly. And your palette can add a reference counter to my account. And when my account has a reference counter on it, we do not allow it to be deleted. We say something else in the blockchain is holding or using your data, and therefore you cannot delete it. And then if you want to delete your data, if you want to transfer your whole balance, you must go through, clean up your data, which will then remove the reference counter, and then you can delete it. Is everyone generally familiar with the idea of a reference counter? Yeah, okay, I haven't heard. If not, I can just explain briefly. But the reference counter, I think, is pretty, a marker for whether or not this is being referenced somewhere else, right? So does the goal make sense? The goal is we want to clean up accounts, but we don't want to clean up accounts where they would leave behind other data. That's contrary to the whole goal, right? So we add this reference counter. So let's go take a quick look at reference counters inside of Substrate. Yeah, a question? Why don't we get the question while I'm looking? Oh, just scratching. Okay. No problem. Scratching is allowed. Stretching. Oh, stretching is allowed. Scratching is allowed too. Both are allowed, okay? Yeah. You can't yawn though. If you yawn, that means you're not as excited as I am about this topic, man. Out. Okay. What am I doing? I'm looking for reference counters in system. So let's go look at the account type. So all of this is on account data. Account data? Is there an account data type? Yep. Account info. Account data, struct. Yeah, here we go. Account info. It's called account info. Okay. So this is the base level data for all accounts in our blockchain. Remember, yesterday we saw that big spike of the entries in our database. That spike was at a number of bytes equal to like these number of bytes. So however many fields here plus the balances information, that is like a fixed set of bytes. That's where all the users are, right? They all have the same amount of data in our blockchain. So as I mentioned before, this data here is customizable. We have this really cool hook with balances, so we can shove balance data in here, but it's not required. But what is required for all accounts is a nonce, right? Do we know what nonce is used for? We talked about that in blockchain stuff, right? Okay, we know that already. Consumer reference counters, provider reference counters, sufficient reference counters. Okay, this is the same API from Fortitude and this and that. Yes. Okay, so let's try to understand the intention of these words or the intention of these counters rather than just the words themselves, right? Let's read it. Consumer reference counters. The number of other modules that is currently depending on this account's existence. This account cannot be reaped until this is 0. So how many other palettes are consuming this account, are using this account? Okay, provider reference counter. The number of other modules that allow this account to exist. This account may not be reaped until this and sufficiency are both 0. Providers. So this is a module which they can say, I have the authority to say this account should exist. Okay? Finally, sufficiency. The number of modules that allow this account to exist for their own purposes only. This account may not be reaped until this and providers are both 0. Okay, so let me try to explain this logic. Let's assume these two are the same, right? You have like consumers and providers. Now this one is like a elevated provider, but let's just assume these two. I am a palette. I want to put a consumer reference counter on a account. I want to say this account. Gosh, why is it doing that? This account. Oh god, no. Consumer. Okay. Consumers. Oh no. Okay, here. I want to consume an account. I want to use it. What we require is before you can use an account in your palette, that it must be provided by another palette. For example, you must have a balance. When you get a balance that's above ED in balances palette, the balances palette will add a provider reference counter. it is saying to the rest of the blockchain, you can start using this account. All accounts with zero balance have no providers. Therefore, if you try to use it, we'll stop you. We will not allow you to put a consumer on it. This is basically a way to tell other palettes this account is actually real. Remember, all account IDs are just bytes, right? It's just general. So for you to actually know this account is actually being active, we check if there's a provider on it before we allow you to add a consumer on it.
Another example for providers, please. Not existential deposit.
You could create, in your gaming chain, you could create a provider on a register user. You make a function called register user. The user can have zero balance, but you can put a provider counter on it. And now that user can start being used by other palettes. Without a balance. This is how you can support a zero balance system. Another question?
Yeah, so in that scenario, like when I was like debugging my test before, and I saw that, I got to this part basically.
Yep, this error.
Yeah, and that was because it didn't have balance, right?
It didn't have a balance. So it didn't have a provider.
Yeah, it happened as I think I was transferring to it. So like
Okay.
it should be like an initial.
So when you transfer to an account,
Yeah.
the balances palette doesn't require a provider. It will create a provider when the balance is through. But it will. But if you do transfers with an assets palette,
Yeah, that's
the assets palette is not an authority of the blockchain. Does that make sense? The native currency is an authority of which accounts
yeah.
can and cannot exist.
Right.
Sorry, 1 second. I'm gonna put the power charger on my brick. I think it will last. It'll keep the screen on longer.
I think.
But the native balance is the authority of which accounts are actually real, which ones actually live. The assets palette requires that you must have an account that is actually real to be used. So
So the logic for like basically where I was failing was because the assets palette says I want to have one consumer, right?
yes, I want one consumer, but it has no providers.
Okay, but how does it make sure that that consumer is the native balance? Like,
It doesn't. It doesn't matter. So again, the logic of your blockchain, you can create your register user palette, which adds a provider, and then your user can have asset without a native balance.
so for example, I have like a user registry for
Yep.
my game, and then that. right?
Exactly.
Yeah.
So, but again, the default, like again, not thinking about specific scenarios. In general, it makes sense that the balances palette will create a provider. Like it is that kind of a palette, right? It's that kind of idea. But no, again, why I want to teach you this is knowing this logic, you can design whatever palette you want to actually provide your own providers, and then all of a sudden, all these other palettes which want to consume will start working without the balances palette. You can do it yourself.
Okay. Isn't it? Doesn't it make sense also that there would be like a type of provider that like I want this account to have a provider of this type? Like for example, if I have my game registry, right?
Okay.
Then
You want to be more specific. I think. Let me see. Is this sufficient?
like I want to make sure that someone is passing me an account of something that is from my game, not just something that has money.
I think that this system is not generic enough to support that, but you can imagine, you can build that system. It should be possible for you to build another layer which manages specific providers, and then in the background handles just passing it to 1 or 0, right? Like you can have an additional abstraction layer. But this is not built in the system, we're keeping it a little simple. But I think that's possible to build. Okay. Last thing, okay, so everyone on the general same page as consumer providers. We get that idea at high level? Question? Yeah?
First thing, consumers and providers, is it redundant and just made it here so that easily accessible in the term? If it is providing, then someone else is consuming. So I don't have to maintain at both the places.
No, it's not redundant. When you have just a balance, you have one provider and no consumers. You do not get a consumer automatically. When I have a balance, I get one provider, no consumers. And then when I stake in staking, I get one consumer.
Okay.
And then so I can have one provider balances, and then I have no consumers. I go into staking palette, get one. I go into democracy palette. Now I have 2. I go into, in terms of consumers. Now I go into my gaming palette. I have 3, right? And then I cannot transfer my balance to drop this provider until I remove the other consumers. And then I have 0 consumers, 1 provider. And now I can transfer my balance.
Okay, got it. Thank you.
Okay. Now the last one here is sufficient. The number of modules that allow this account to exist for their own purposes only. So this is a backdoor, right? So in this context, a provider allows any number of consumers to exist, right? If I have 1 provider, you can add consumers. But you may want an account to exist for your purpose only, but other palettes cannot consume that account. In that case, you put sufficient. And if you remember, inside the assets palette, there's that Boolean, sufficient. Is the asset sufficient? In this context, this would be something like, I allow you to, in Polkadot, without having any dot token, I allow you to own USDC. But because you own USDC does not mean you can use staking palette, you can use governance palette, whatever. We do not allow other consumers to consume you. We just allow you to own some account that lives for your one purpose. And these are exactly the scenarios in mind. There are probably other ones you can think of, but the idea is that with a sufficient, your account, your data is allowed to live in the blockchain. We won't clean it up for you. We will keep your data around, but only for your purpose. Whereas a provider, like the balances palette, is a signal to the whole blockchain. Everyone can use this account. Okay? So let's so let's look a little bit. So the APIs here. There is a function, add consumer, something consumer. So inc ref. Okay, no, sorry. These are deprecated. So use inc consumer instead. So there's inc provider. So these are all public functions in frame system. So you can access them with this, right? You can access them frame system palette t inc providers 2, right? There's, oh my god, 2. So this is how you can access this function. So in every palette uses frame system. Everyone can access these functions directly, okay? There's the ability to increment providers, decrement providers, increment sufficient, decrement sufficient, increment consumers, decrement consumers. Okay, here's increment consumers without limits. Where's that? Increment the reference counter of an account, ignoring the max consumers limit. So I guess there's a limit somewhere configurable inside of a frame system with some limit. This ignores that limit. Where's the one with the limit? Up here. It's checking. Again, you all should feel comfortable. There's some kind of configurable constant on the max number of pallets can be consumed. And this kind of makes sense, I guess. I mean, I would think like, okay, if you own 1 dot, should you be able to make 1 trillion consumers? No. 1 dot is not enough to put 1 trillion data in your blockchain. You could have a pallet where every time you do some operation, we increment your consumer, right? So in this case, 1 dot is enough for 20 items. And if you want more, you have to build some other system. You can imagine these are tools, you can use them, right? And then of course, I'm not going to go over it, but you can look at the logic in these pallets. You can imagine, for example, when you remove sufficients, and there are no, when the sufficients and the providers of your account are 0, you kill the account, right? So this is the logic where you're doing the increment decrement, and when this point is hit, you can support killing an account. Yeah, good question.
Shawn, if I freeze balance,
Yeah.
Will that increment the providers, or
That's a great question.
that's the matter of balances palette only, or?
Let's go look. Balances palette. So I'm going to be looking for these APIs. So in the impl fungible, I should search for inc consumer. Oh. Inc. Okay, let's just look at the whole palette. This palette's making me look bad. Inc. There we go. Here, things showing up. Okay. Balances. So here, what is this? This is Genesis config. So in the Genesis config, whenever we endow an account with money, you see the first thing we do is we increment provider for all of them. So for each account that gets money, we increment the providers. And then there should be some logic somewhere. Ensure upgrade, that's not really super useful. Ensure upgraded, not super useful. Try mutate account. So again, the balances palette is quite complicated and quite optimized for a low-level native balance. But somewhere in here, you can imagine, we're trying to mutate an account, the balance. And there's logic in here to handle the providers and consumers. And let's look maybe more at where consumers are. Consumers. So in consumer, this is for the upgrade thing. This is for try mutate account. Try mutate account. Let's see, I think I need to do better. Did consume, does consume. Frozen or reserved. See here. When you create any hold or any frozen, it will ensure that you have a consumer account. So when you create a frozen, it does use a consumer.
Freezing is an overlapping operation. So if I have one dot and some function is just freezing one dot, then another function is also freezing one dot, that will be successful, right?
Yes, but it won't cause two consumers, it'll be one consumer.
Oh, okay.
So again, the idea with reference counters, it's not, it's kind of up to you to design how you want to use it, but the general idea is the reference counter should be at a per palette level. Your palette has all the logic it needs to understand how it's using the account.
Okay.
It only needs to put one item to say, we're using this account. How exactly it's being used, you shouldn't delegate to reference counters, you should keep that logic on your side, right? So you can have, I'm using this account for 5 reasons, this turns into one reference counter on the system, right? This is just efficient programming.
Okay, thank you.
Okay.
So when we are doing the voting palette, shall we add the reference counter, like consumers ref by ourselves, or it does it automatically?
It doesn't do it automatically. That if you want to add it, you need to add it yourself. It is very easy to add. So like where you do vote, you do add, and where you do clean up my vote, you do remove, right? It's not required for this. It's not required for this project. I don't really care if you use it or not. It's also easy to fuck up. Like imagine the worst case scenario is you do add, and then somehow you forget remove, and you have an account that can't be deleted. But if you want to add it, it's just literally adding 2 lines, and you have to make sure in your logic that every add has an equal number of removes, right? You also actually I said something that wasn't a bad fuck up. The real bad fuck up is you remove a reference counter when you shouldn't have, because you're removing someone else's reference counter. That's really bad. You're all playing with one storage item, right? So, but again, with your voting system, I would say in a production system you should do it, and it's very easy to add. It's just call inc and call det. Okay.
Okay, another question about the sufficient field. If a count doesn't have like providers, but it's sufficient is true, so the count exists, but it cannot be used by other palettes. Is that right?
So, okay, so your question. I have sufficient, but I do not have provider.
Yes.
And your question is, can other palettes use it? The answer, I believe, is no. And it would be easy to write a test. We can actually write a test real quick right now if you want. But my belief, based off of the docs here, that I can add a sufficient, which will tell frame system, keep the data. But when I call consumers, it will not accept this. It will only look for providers. So I think we can do a basic test. Let's just do a little bit of coding. It takes 1 second, I think. Let's try this. So we go into our project repo. This is the project you're all working on. What palette are you doing? You're doing Dex, multisig? Give me one. She's voting. Okay, great. So voting. Yeah, that makes sense. Obvious. She just asked about voting. Same thing. Let's go to voting. Let's make a test. And we're going to do this. And we're just going to do a function called playing with reps. Okay? And I think testing this is super. In my head, it should be super straightforward. I'm going to have let Alice equal 0, and I'm just going to call frame system palette, test, ink, sufficient. What's the API? Ink, ink sufficient. Where did I go? Okay. Ink sufficient. And I think it doesn't, it requires who? It requires Alice. Probably requires ampersand Alice, okay? Let's just try to call this function, right? And it should be assert, okay. Just start here. Cargo test palette photo. Ink ref status. Okay, so there's some kind of status I need to handle. So just give me 1 second real quick. Let's figure out that. So this ink sufficient returns ink ref status. Ink ref status is enum. It has the option created and existed, and reaped and exists. Okay, so let's add that real quick. So I'm gonna import frame system ink ref status. So use frame system ink ref status, and I should then, instead of assert okay, assert equal ink ref status created, right? Is it created? Created. Okay, let's try that. Okay, so 2 questions. So the first, we should do this. Before I do any reference counters, my assertion is you cannot put a consumer on an empty account, right? A consumer should give me unreferenced, maybe? Let's do ink consumer gives me an error. This is dispatch error, okay? So in this case, I should do assert NOAA. And I don't know what error it's gonna give me. So I'm just gonna put a big error in here. I can actually just do assert okay, and it'll tell me what error it is. This is what I would do. So this should fail, but I wanna know what error I get. Okay, in consumer, and consumers, thank you. It says no providers. So there's some kind of error. I'm guessing dispatch. Oh, maybe it's a system error. It's going to be, so I'll show you this. So you can do type system error equals frame system error runtime or test. Right? So I can do system error no providers. That should be a certain no on. Figure out no. It was in dispatch error. My initial thing was correct. Dispatch error. Use frame SP runtime dispatch error. Sorry, my lips are getting chapped. Okay, so this works. So obviously with a brand new account, I just showed you cannot add a consumer, right? Because we need a provider. You asked if I put sufficient, can I put a consumer? And my guess is also no. My guess is that sufficient is not enough for other pellets to consume. And it passes. So that means that it does not allow it. But as soon as I put as soon as I put a provider in providers, Alice, and I guess that will be ink ref that was created, then I can ink consumers. Right? I can ink consumers. That would be okay. And then I'll show you that I cannot decrement. Okay, sorry, great. It not created, it existed. So I guess this is telling me that the sufficient already me, okay, why would that be useful? I can imagine this is useful if I have a hook where when an account is created, I want to trigger some logic. The account was already created using sufficient. I don't want to trigger the hook again, just adding a new provider. Or consumer, provider, right? Okay, anyway, so it already existed this year. Now it's going to fail. It's going to fail to decrement the consumers or to decrement providers. Right? Let's try that. That providers should know of dispatch. I don't know what the error is going to be. That should be good. Dispatch error. No provider. But that's obviously not correct. Assert. No one. Let's try that. Consumers remain there. Which makes sense, right? Any other behaviors you want me to check real quick? Okay, good. Any other behaviors? But it makes sense, right? I mean, again, a lot of the way you can best understand a lot of the logic inside the substrate is writing your own tests. You don't have to, reading the code is kind of crazy, right? It's hard to follow all the logic. Here's the basic process. I read the docs, I had a basic understanding. I want to verify the understanding. Here's that understanding, okay? Any questions about reference counters? Again, this is not an important part of your exam. All of these topics are extra topics, but you hit these things. I kind of hide from you, oh, don't worry about it, do this, do this, do this. Now you're actually understanding what's happening in the background. And again, with this knowledge, you have the ability to do more advanced things. Knowing now that you can backdoor create your own providers, you can now unlock accounts beyond the balances palette. Right? Great. Format. Let me push this. Yeah, just talk in the mic. You have it ready. Can you get a mic to him, please?
Because the counters are simply counting, not really pointing to which function incremented it or decremented it. If I increment for one purpose, that can be misbehaving for other purpose.
If you have a bug, that you're saying? Okay, you have a bug?
Even intentional, like if I give sufficient here, I intended just to make sure that in the palette asset, it can have some assets without having the dot. And because I incremented sufficient. There can be other palettes where assets, I mean, some operations are happening based upon the sufficient logic, which will be misunderstood.
No. Sufficient is something you control. So when you put sufficient, and there's another palette trying to get a consumer, it won't work. There's no misunderstanding here. If you put sufficient, you're saying that only your palette is good for the data.
Okay, yeah.
If you put provider, that's different. And if you put provider because you want only your palette to use it, you should use sufficient.
Oh yeah,
Sufficient is
makes sense.
exactly designed for you to create an account without other palettes depending on it.
Okay, thank you.
Yeah. Okay. Any other questions on reference counters? All right, the last topic is palette instances. Okay? So, what is the goal of palette instances? I think there was already a question, I think in chat someone asked, and I didn't answer, but this is my opportunity to answer. You have learned how to create these awesome palettes, these modularizable palettes. You might want to actually use the same palette twice inside of your runtime. I'll give you an example. There is a collective palette, which is what is used for the fellowship. You might want to create a developer fellowship, and also a marketing fellowship, and also a business development fellowship, or whatever. You could use the same collective palette multiple times. It could also be something crazy. You want two native assets. You want a dot asset and this other asset, both with some similar, not using assets palette. Now, of course, you have learned, or you can understand how you would be able to extend your palette to multiple dimensions by adding maps, right? Like you can map to some index and etc., right? But there might be a case again where you want to use just the same palette 2 times. Okay? That's and we do use it inside of Polkadot. We do have multiple collectives. What would be the problem with adding the palette twice into your runtime?
The common state will be used everywhere.
Yeah.
Like the balances palette definitely living in so many other palettes.
Yep.
So there is a centralized place for balance accounting. In the same way, if you use other palettes also at the multiple places, their is centralized. I mean, their state will be common to all other palettes. If you don't want that, then
I think you're kind of right. It's not exactly what I'm thinking, but like, so there could be problems with storage, maybe. There could be some problem with storage, but in general, it shouldn't be a problem because the storage prefix is based off the name that you define, and the name has to be unique. So balances 1, balances 2 would be different names. The main thing you want to avoid is type safety. Actually, it's type safety. When I'm talking, oh gosh, what's happening? When I'm talking to a palette, am I just screaming too loud? Should I charge it just yell right now? Oh God. Alright. Yeah, I can do mic and then. Better? Oh, way better. Oh my gosh. Okay. The main thing actually here, I mean, there is some stuff with storage, I'm sure, and other things, but it's type safety. It's that when I'm instantiating 2 versions of a palette, I want to be able to very uniquely identify which of the palettes I'm using. Like I'm calling into the same crate. I'm calling, there's a crate called palette balances, right? And I do : a palette struct, right? But if there's 2 of them, which of them am I calling? The crate is just 1 crate. 2 instances. So really what we're trying to solve here is a type problem. How can Rust instantiate 2 structs, right, that are different? Of course, it's using generics, right? Generics and type stuff. So let's take a look quickly at what is going on with instances. So I think I'll show you by first showing you an instance inside of Polkadot, and then a little bit of the code that makes it work, okay? So let's go into the runtime. No, the runtimes folder. And then if we go to, let's say, Kusama, if we search the word instance, here we go. So in this case, this is a bad example. It's not a bad example, it's just like, I don't think you guys know what a bags list is, so it doesn't really it's not really like super directly relatable. Palette instance filter. Here we go. Palette balances 2. Oh, here, that's interesting. So here, in Kusama, we have 2 balance palettes. This is not actually being used actively right now, but it exists, and it's in there. So again, I mentioned you might want to have 2 native balances for some reason. Here is palette balances instance 2. And we are implementing palette balance config for this instance. Do you see? That we're not just implementing palette balances config, we're implementing the config for this instance. Now we have literally different type safety. Rust understands difference between 2 different uses of the same crate and the same trait. We are able to define them differently because we have this instance. Does that make sense so far? And this palette balance instance can have all different config than the other palette balances. Every single type, every single trait, it can be different. So it can be U32, it can have a different exercise deposit, it can have a different rules, different freeze, different everything. Because this instance is just identifying a difference in types. Okay? So we have here this. Let's see more stuff. So let's look at this NIS counterpart instance. Where else it shows up. So it's showing up here, like, oh, look at this. There are other places where you might need to be generic over this instance. So again, whenever you're specifying, I'm using palette balances, instead of just saying palette balances some type runtime, right? Normally it would end here. You're saying runtime, comma, and instance. Let me say this one more time. Instead of saying some type, or instead of saying T, that's a bad example. Instead of what I call storage, instead of calling balances colon T colon get, right? I need to call T comma I. T comma and an instance. So I can uniquely identify not only the runtime I'm working in, but the runtime has two instances, which instance in that runtime. So two generic parameters will allow me to identify both the runtime and the instance. Here, account, this is a type where normally you have just T, you've all been doing just T, you can do T plus I.
So the second generic parameter we have not been defining so far. So
Yes.
is that a default definition?
Yes,
there?
and I'll show you that code.
Okay,
It's
okay.
exactly default, okay? But let's just keep going. Let me look at more into here, what the instance is being used. So you can see here, types are being defined with this instance. I guess that's it. And then I guess here, I want to see, I guess, is it included inside the runtime? That's my question. That's kind of palette balances. Oh, here we go. And NIS counterpart here, NIS counterpart balances, and we add the palette with palette balances, and then instance 2. Okay? So we can just add, again, a second palette balances with a different instance. Okay? And let's look at the initial definition. Do we even need an instance in the initial one? That's a question, right? Where's balances? Here. We don't even need to specify instance 1. Instance 1 is default or something, right? So let's look at how that works, okay? But any questions so far? You can imagine, again, just adding a second generic, you're able to identify a whole new unique type. Rust understands these are two different types. They can have two different states, two different configurations, and you can use it twice. So in the background, what's happening? There is this thing called palette instance. I think it's an enum palette instance. Palette instance. Is it not an enum? What would it be if it's not an enum? Let me search instance 2. Instance 2. Instance 15. Instance 14. And what am I in? I'm in runtime. That's why. I'm in Polkadot SDK. Let's try my idea again. Enum palette instance. Nope. Instance 14. Here we go. Okay. Here's the folder in frame support instances. Let's read this doc. Some instance placeholder to be used in frame support palette attribute macro. The palette attribute macro does not only require the instance generic I to be static, contrary to whatever, but it requires instance generic to be implemented frame support. That's probably some old stuff. The support provides some instance types to be used. This allows some instantiable palette to depend on specific instance of another. So it allows one instantiable palette so you can have one instantiable palette depend on specifically a specific instance of another palette. And we can see here, there's just empty structs just defined, where we can just use these structs as an anchor point for our different types. So we have instance 1, 2, 3, 4, 5, etc., all the way down to 16. Okay? So we can plug these in, they're usable in there. The final question is, what is the default instance? That is defined in our palette. So let's go look at an instantiable palette. An example is balances, right? If we go to, I think actually treasury will be easier to look at. So let's look at treasury, because I think balances is just a lot of code. So we're going to look at treasury, but it's exactly the same for every palette. Treasury, source, lib. Look at this. Who has looked into treasury palette and started wondering what this I has been? T config I. This is an extra thing that you haven't been doing, right? You don't need to do it, but we can pass this I, and look at this. I is static equal parentheses. This is the same trick I taught you when you put asset ID equals 332, or you put num equal to the other num. There is some I, and I'm saying by default, if you don't define it, it's the null type, right? And so when you have an instantiable palette, and you create an instance of it without defining an instance type, it just uses null. Otherwise, you can use instance 1, 2, 3, 4, 5, 6, all the way to 15. right? So what would you need to do to make your palette instantiable? You just need to go through and make everything I. Again, everywhere, like, and there are PRs you can look at, which I think take a palette and turn it instantiable so you can see the exact diff. But in general, you start with this. Struct palette, instead of just T comma I equals parentheses, T comma I, and then you're gonna get errors that you just need to go fill in the rest of the I. So everywhere, pub trait config, I, static with the unit type. Every single time you define an object, self comma I, self comma I. So again, wherever you did the self, wherever you did T, one level deeper, right? It's just everywhere, self comma I, self comma I. Inside of proposals, T config on I, where I is static. Proposal, balance of T comma I, everywhere, right? Everywhere. T comma I, T comma I. And again, the idea here with this balance of T comma I, let's look at that real quick. The balance type in here, there should be something. Currency. Wait, actually I'm not seeing what I expected to see. Here, balance of self comma I. Balance of, where's the balance of type? Balance of, here, right. T comma I equals default. Okay, I'll be honest, I'm a little bit surprised. What I was expecting is I was expecting to see an I in the balances too, but I guess it's not needed. Watch, why is it not needed? It's not needed because this. I define which balances palette I use by implementing this currency trait. You use the fungibles trait, that's better, but I implement something here. So let's go into the config in the runtime. So in the runtime, there is, I think, 2 governance palettes. There's, what else is instance 2? Let's look at this, instance 2. So there's a referenda. So there's 2 referenda palettes, right? So let's look at instance 2. Referenda, where is this? Palette, so palette, referenda, config. Oh, it's in a different file. There's a governance file. These governance stuff have gone so big that they have separate config. So here's the config 1, and then fellowship is probably config 2. Config with a different instance, right? I got confused, but it's right. In this config of referenda, I use the balances palette. You can imagine in the other config, in this one, I could put my other balances palette. So now you're able to have 2 different palettes, also reference 2 different backends, right? 2 different instances. So exactly each config is completely unique for that palette. Okay. Any questions on this? Again, you don't need to do it. If you want to have fun at the end of your project, going through adding the I, it's almost like it's not a logical breaking change at all. It's just a type change. It's going to be fighting the Rust type compiler for a little while. But all the rules there are pretty simple. Yeah, can we bring a microphone up here, please? Right here.
Yeah, question. So is this what's used for the assets palette for Assets Hub?
No.
No.
So the assets palette, instead of using instances doesn't scale. So one of the things that you learned is that the call enub is 1 byte of palettes, 1 byte of the call index. 1 byte is only up to 255 or 256, right? So you can only actually have 256 palettes in your runtime. So if you were to have a blockchain that supports thousands of assets, you couldn't have thousands of the balances palettes, right? It doesn't make sense to scale. Also, it's not dynamic. If you need to upgrade your blockchain every time you want to add a new palette. It's not dynamic. So instead, what the assets palette does is rather than using a simple map from user to balance, it uses a double map from user to asset ID to balance. So you can also scale your systems with an index, right? But there are advantages and disadvantages to it. One being that when you scale it with the extra index, you're making that system inherently slower. You're making everything 1 level of complexity. You're making all APIs 1 level of complexity more complex, right? You're also kind of assuming that my palette should scale to kind of infinity. Like I should have any number of indexes. If I just want 2 treasuries, this is kind of the better way of doing it.
Oh, that specifically is the way you just described it is true for like foreign assets versus like pool assets and assets. It's like
Yeah, in all these cases, you're making many assets, and you're making them dynamically. It should be handled at the pallet level, and there are ways to handle it at the pallet level with more complex APIs, with deeper maps.
Deeper maps.
Yeah, exactly.
Thanks.
To the left.
Just so I understand, like, so what we're doing here is basically like creating actual instance types. Like instead of like here in the example, we do it in the runtime or in the mock, we like instantiate the runtime.
Right. So
yeah,
I didn't like
instantiate the config. Sorry, of the.
Yeah. So it's not unlike your example. If you take the palette you're working on right now, you can make it instantiable. All you have to do is go through where all the T's are and add the comma I.
Yeah.
And then in the runtime, you just pick.
And then you're basically, what we're doing by that is like letting the consumer of our palette like have concrete runtimes. Like
Sure.
with
The
all the types
runtime
provided.
developer can
Yeah.
pick how many times to use it and what they want to configure.
And then we can also limit it in the sense like what you just said. Like for example, if we don't actually expose the.
Yeah, if you don't expose the call or you filter it, then it could be that that's blocked, right? Maybe, if you want to.
Okay.
So I could, if I have two balances palette, I could make a call filter where you can call balances A but not balances B.
Okay. Cool.
So I guess you can see here again that we are using the power of Rust to be able to make our system more modular, extensible, reusable. Again, we really think that not only Substrate is a great SDK, but it's a great SDK because of the choice of Rust and because of the things we can do here. Everything here is type safe, compile time, zero overhead cost, right? So those are the main extras I wanted to share. I hope that you thought they were interesting.